this video, we'll discuss some important information about biospecimen collection. So you've decided to maybe look at some sort of exposure in your research, or maybe some sort of metabolite that might be a downstream effect of an exposure, and you've decided on the type of specimen you need to obtain. Maybe it's urine, maybe it's saliva, maybe it's blood. So now you need to give some thought to how you're actually going to collect that specimen. So it's important to remember that the integrity of your biospecimen can alter even before the sample is removed from the body. So I think a good example of this is many, many years ago when we first started collecting saliva as a biospecimen. We would have participants chew on something in order to initiate the saliva production. And chewing on something actually can have an effect on the saliva being produced, especially if the thing that you're chewing on has exposures within it. We also know that if we're collecting specimens like urine, that the amount of liquid that that person has had to drink that day has an effect on that sample as well, even before it's removed from the body. So when you think about collecting your specimens, you're going to have to think through those aspects as well. Does the individual need to be NPO for a certain amount of time? It's difficult sometimes to, you know, prescribe how much they drink if you're going to collect something like urine, but maybe you need to think about collecting something like specific gravity of that urine in order to kind of wash that out among your samples and control for that factor. So when we think about collection, we have several different elements we need to take into consideration. First, let's talk about the participant. So you need to be sure to consider several factors. Do they have certain health conditions that are going to alter maybe how that exposure is processed in the body, or even downstream effects of that exposure? Are they on medications that you might be picking up and might alter your sample as well? Are there other exposures that they may be encountering throughout their day? Maybe you're interested in exposures to something like arsenic, but do they have other exposures that might impact that exposure, or that you might be picking up that might alter maybe your outcome that you're interested in? What's the participant's diet like? This is a huge consideration when we're thinking about our biospecimen collection. Um, all sorts of exposures occur through diet. So how are you going to control for that? Also, if you're looking at children, you're going to need to think about pubertal development and where they are in that cycle, and whether they began puberty or not. That will also have an effect on downstream metabolites that you might be interested in. And then the same thing with menstrual cycles. So if you're going to be collecting samples from women, do you need to take that into consideration as well? Next, let's talk about sample acquisition. So how you collect your sample really matters. So are you collecting saliva, just having somebody spit into a tube, or are they kind of drooling into a straw that goes into the tube? So how do you need to consider how you're going to acquire that sample? Um, Also think about timing. A lot of metabolites change over time throughout the day. And so you're going to need to be consistent with your timing. I usually try to collect tell participants to collect samples first thing in the morning. And that way I know everybody's collecting at about the same time each day. So when you have diurnal patterns for things like cortisol, you can take that into account if you have that consistency. And just being consistent across participants as well is really important so that everybody collects at the same time in the same way. So next, let's talk about handling and processing. So some things that you need to consider is when once you obtain that specimen, are you going to need to preserve it in some way post collection at the site where you collected it? You need to think about timing for transportation. So I do a lot of samples out in the community. I go to participants' homes and collect my samples, and then I have to transport it back to the lab. So how am I going to do that? Do I need to transport that at room temperature, or am I going to need to bring dry ice with me in order to transport that? You've got to consider stabilization of your sample as well. How long is it stable? We're collecting right now some stool samples for microbiome assessment, and we purchased a particular um, vial that actually has a stabilizer in it, and that sample is stable for up to 7 days at room temperature. So you got to consider that as well. Also think about once you get the sample back to the lab, you're going to need to aliquot it out of whatever you collected it into and put it into some little tubes to store in likely in your freezer for when you want to actually do the analysis of the sample. So what's that process going to be like? You need to plan that in advance. How many aliquots do you need? What type of data are you going to be trying to get from this sample? Are you going to be looking at metabolomics and then also targeting a particular analyte? Then you might need to have 2 aliquots of that particular sample. And then kind of going along with that, what additional measures do you need to consider with the sample that you've collected? It's not unusual to get extra urine, and maybe there might be some things that you add later on. You also need to think about how you're going to be storing your sample. Obviously, there are oftentimes specific requirements with regards to temperature. Do you need a minus 80-degree freezer, or is minus 20 okay? Can a sample just be refrigerated, or can it stay at room temperature, and for how long? Um, Also, remember too, there oftentimes with microbiome research will receive a tube that we're collecting the sample in. It may be in some instances that that tube itself can be stored in the freezer for any number of days, years, months. But some of them will require after maybe 6 months to be aliquoted into another type of tube. It just doesn't store very long in the freezer that way. So you need to kind of take that into consideration as well. And then also be thinking about, because typically what happens is we collect our samples over many months, oftentimes years, and then we're going to send it all to the lab at the same time. So how long will you need to store it? And are you going to continue to store samples even after doing this particular study that you're currently funded for? Are you going to continue to store those samples? How are you going to do that? Where are you going to do that? Next, let's think about distribution and shipping. Oftentimes, I already mentioned transportation from maybe the site where you're collecting to the lab, but also oftentimes the lab that we store our samples is different than the lab where we actually do the analysis on the machines in. So how are you going to transport it between those different locations? Um, I have also collected biological samples that I have shipped to another state, to another lab. So what's that going to be like? What's the cost going to be like? What are the requirements for shipping? Where are you going to ship it from? And what type of materials do you need? You can't just ship biological samples from people from one place to another. That has to be thought out as well. Only certain places will allow you to do biological shipping, and it may require additional expenses. And what temperature does it have to stay at when you're shipping your samples is another important consideration. And then finally, analysis. So do you have validated assays when you do your analysis. So it's important that they're done in a lab where they have um, that particular analyte that you're looking for already validated. Also consider the laboratory's standard operating procedures for how they do these assays. If you're doing them yourself, obviously you're going to need a copy of that and to go over that and review that, make sure you understand that. But even if you're sending it off to an established laboratory, getting that information up front will be really helpful so that you can speak to it as you need. Um, Consideration for, are you going to need certain reagents in order to be able to do the analysis in the lab? That those might be additional purchases that you have to take into account. Knowing that up front will really help you, particularly if you're doing grant writing to get funding for support of this research. And then randomization, how are you going to randomize your samples in the machine? And having a well thought out plan for that is really important up front. Finally, it's really important that you have good, clear, and thorough standard operating procedures. And that goes throughout this process of biospecimen collection. So, um, I spend a lot of time putting great detail into how I'm going to collect it so that even if I'm not collecting the sample, if somebody else has to pitch in for me and go out and do the data collection, or we have a research assistant doing that, they have the exact process that I would use if I were going out there. And that's really kind of well thought out. And it includes things like, you know, what types of tubes to use. Don't forget tissue. If you're collecting saliva, people like to kind of wipe their mouth afterwards, right? And exactly how do you do it? And even down to once you seal it up in the tube and put it into a container for storage for transport, all of that needs to really be detailed in your standing operating procedures, as detailed as you can about all the elements we just talked about. The better off you will be. And this is also really important information to include in any sort of method section when you're submitting your grant as well. So that's the end of this presentation. Thanks again for listening.